Good day, guys. This is tutorial in Covenant University, and we are taking linear programming today, equal 215. So, before I start the main calculation, I want to give a brief introduction of what linear programming actually is. So, linear programming is like a topic in operational research which deals with maximization of profits, to know the constraints, to know how the resources within a given organization can be constrained to achieve a particular profit. So now, for example, now this is just history. It is a mathematical technique of practical importance. Since the origin of linear ramming in 1940, there have been important theoretical and computational development, and its method is now used in various parts of the world. Like for example, let me say a company like Chivita now, obviously they will need stuff like orange, they will need stuff like sugar, they will need stuff like water. So when they're trying to maximize these items, okay, how much orange will I need? How much orange, sugar, and water will I need to give the best output? You understand? So that's just like an example of linear programming. So why linear programming? Linear programming is used because it's the mathematical method for optimizing a linear objective function while satisfying given linear constraints. So that example I gave, the water, the orange, the sugar, those are the constraints. So the objective function now, those three items now, how much will I use to give Chivita A and Chivita B? If I mix them together, will I achieve this particular profit? There is a profit that I have to aim for. Now let me just assume the profit is 150,000. So that 150,000 naira is the profit that I'm trying to maximize. So the baker wants to maximize, so this is just an example. The baker, for example, wants to maximize profit, which is a key characteristic of LP problems. So the objective function now. So now let's just assume this x1 is distributor A, this x2 is distributor B. So 20x1 plus 30x2, which is 20 distributor A bottles and 30 distributor B bottles together, will yield a particular profit function. But may I given the profit that is here? So let's just assume that the profit is greater than, less than or equals to 150. So that's the profit function. So linear constraints now. Okay, now earlier here they gave cake as an example, a baker. So what will a baker need to? So what are the resources that the baker will need? Flour, sugar, and butter. And they are represented as linear inequalities, meaning that they do not have exponents, square root, or nonlinear terms. So non-negativity variables, obviously, I cannot yield minus 30 Chivita A bottles. I cannot bring yield minus 20 Chivita A bottles. That means all the constraints, all the variables within that given equation, they are all going to be positive. They are never negative. So this is the solving method. We have two major methods. We have the simplex method, we have the graphical method, and we have the normal geometrical method where you just like solve normally.